Welcome mathematicians. In this video we'll be looking at calculating the gradient from coordinates, or if you like, points. So I have here a graph showing 2 points, point 1 and point 2, and the general equation we can use to work out the gradient, which we use the symbol m for. So let's look at 4 examples. So in our first example, we're asked to determine the gradient of a line between the points 2, 2 and 6, 10. Let's look at this visually on an XY plot. So the point 2, 2. This is using a Cartesian coordinate system where the first number represents an x coordinate and the second a y. The first coordinate x is the value 2. So x equals 2. Here's the line representing x equals 2, and the y coordinate, the second number, is y equals 2. So these two coordinates intersect at the point shown, and we label that 2, 2. It means an x of 2 and a y of 2. Our second point has an x value of 6 and a y value of 10. So we find an intersect point at the top here, and we label that point 6, 10. So we have our 2 points and our line joining. Now the task is to determine the gradient between these 2 points. So the next step, imagine we have a vertical ruler and I move it from the left-hand side of my graph until I reach my first point. Okay, that point 2, 2 I will label as point 1. It's the first point I've met with the vertical ruler moving from left to right across the graph, which means if I allow that to continue, the second point I reach is point 6, 10. At point 1, I have an x value and a y value, 2 and 2, and we label them x1 and y1. That makes sense. Point 1 has an x1 and a y1, and point 2 is labeled x2 and y2. The equation to calculate the gradient, and we use the symbol m for gradient, is y2 take y1 divided by x2 take x1. So y2 is substituted in for 10. So 10 is substituted in for y2, and 2 is substituted in for y1, 10 take 2. And 6 is substituted in for x2, and 2 here, the x1 value, is substituted in for x1. So we end up with 10 take 2 over 6 take 2. 10 take 2 is 8, over 6 take 2 is 4. 8 over 4 gives me a gradient of 2. So the gradient between the point 2, 2 and 6, 10 is 2. Let's just check that. It's a positive gradient. And if I start at my first point and move to my second, yes, I'm going upwards. So that should be a positive. And a gradient of 2 means every time I go across 1, I will go up 2. So effectively, if I go from 2 to 3 on the x-axis, that means I'm going from 2 to 4 on my y, across 1 and up 2. So we can check our answer. Our second example, determine the gradient of the line between the points minus 10, minus 4, and 10 and 4. Again, we want to plot these points. The first point has an x value in the Cartesian coordinates of minus 10, somewhere along this line on the x-axis. And the second point, minus 4, is the y-coordinate. So here's where the two lines intersect. So this represents our point minus 10 and minus 4. X of minus 10, y of minus 4. Our second point has an x value of 10 and a y value of 4. Now where they intersect is the point 4, the coordinate 10, 4. And here's our straight line. Once again, I grab a ruler from left-hand side and I move it from left to right, and the first point I touch, I'll label as point 1. And I'll continue that on to the second point I touch, and I'll label that point 2. So I now have my straight line with a point 1 reference and a point 2 reference using Cartesian coordinates. Let's look at labeling these again. So point 1 has an x value and a y value, x1 and y1, and point 2 has an x value and a y value, x2 and y2. The equation for gradient was y2 take y1 divided by x2 take x1. y2 was a 4, we sub that in, and y1 was minus 4, we sub that in. x2 was 10, subbed in, and x1 is minus 10, subbed in. Now, 4 take negative 4. The two negatives effectively act as an addition, and 10 take negative 10. Again, the two negatives act as an addition. So we end up with 4 plus 4 gives me 8, and 10 plus 10 gives me 20. So my answer here is 2/5. So the gradient between the point minus 10, minus 4 and 10, 4 is 2/5. Now that's a positive. Let's start at our first point. And yes, we are going uphill. It's a positive gradient to our second point. So that's correct. And it has a gradient of 2 on 5, which means for every 5 we go across, so from minus 10, 5 to minus 5, we go up 2. So that's true. So we go across 5, we go up 2 on our y-axis. So 2/5 is the correct measurement of the gradient. Example number 3. Determine the gradient of a line between the points minus 4, 8 and 1, minus 2. Let's look at this graphically. The first point has an x coordinate of minus 4 and a y coordinate of 8, and they intersect at this point here. So we put a dot and we label it minus 4 and 8. Our second point has an x coordinate of 1 and a y coordinate of minus 2. Now where they intersect again, we put a dot and we reference that, or label it in brackets 1, minus 2. That's the x and the y. There's our line between the 2 points. Again, let's move a vertical ruler across our graph from left to right. The first point we'd strike is our point 1, minus 4 and 8. If we continue that process, the second point we strike is our point 2, which was 1 and minus 2. So we have our diagram here with our 2 points, our line between the two, and we've labeled them point 1 and point 2. So point 1 has got an x value and a y value, x1, y1. Point 2 has an x value and a y value, x2, y2. Substitute these numbers into our equation for m, the gradient. So y2 was negative 2, y1 was 8. They're subbed in. x1 was a 1 and x2 was minus 4. Negative 2 take a further 8 becomes negative 10, and 1 take away negative 4, the two negatives act as an addition. 1 plus 4 is 5. So I have negative 10 over 5, which I can simplify to minus 2. The gradient between the points minus 4, 8 and 1, minus 2 is negative 2. Let's check this first of all. I start at point 1, and by the time I get to point 2, I am going downhill. It's a negative slope, so that's correct. And it says the gradient is negative 2, which means when I move to the right by 1, say minus 4 to minus 3, by the time I go halfway across this grid, I have in fact dropped from 8 to 6. So I'm moving to the right by 1, and I'm moving down the y-axis by 2. So it is a value of negative 2. Just checking our answer. Our fourth and final example, let's determine the gradient of a line between the points 0, 4 and 8, 0. So here's our graph. Point 0, 4, first of all, has an x value of 0 and a y value of 4. Where those points intersect, we put a dot and we label it the coordinates 0, 4. Our second point was the point 8, 0. We have an x value of 8 and a y value of 0. Where they intersect, we put a dot and we reference that, the point 8, 0. So here we have our point with our line joining the two. Once again, let's label them correctly. So if I place a vertical ruler on the left-hand side of my graph and move it across to the right, the first point I hit, 0, 4, will be called point 1, and I continue that pattern across. And the second point I hit, 8, 0, will be labeled point 2. Once again, point 1 has got an x and a y value, x1, y1, because it's the first point, and point 2 also has an x and a y value, and we label them x2, y2, because they're the second point. Our equation for our gradient is as follows. Let's sub in our values. y2 was a 0, we sub that in. y1 was a 4, we sub that in. x2 is an 8, we sub that in. x1 is a 0, we sub that in. So 0 take 4 gives me minus 4, and 8 take 0 is 8. Minus 4 over 8 gives me a value of negative a half. Okay, let's check that. From our first point to our second point, yes, it is moving downhill, so negative makes sense. And the half, if we look at this, every time you move across 1, we find the gradient only goes down a half. Okay, if we moved across 2, it will go down 1. If we move across 4, it will go down 2. Okay, so it's actually only declining by a half every unit we move across in the x direction. So the gradient between the points 0, 4 and 8, 0 is negative 1/2. Thank you for watching this video on calculating the gradients of two Cartesian coordinate points. If you've enjoyed this video and in fact learned something, please like, share, comment and subscribe. And as always, thanks for watching.